Okay, welcome to this video 2.8 guys, decimals and fractions. Your learning goal is still being able to use fractions, decimals and percentages and their equivalences, and you should be able to perform conversions between the decimal and fraction representations of a number. Alright, this way and that. In a few videos time we're going to be talking about percentages, and you'll see soon that fractions, decimals, and percentages. That's me trying to draw an X. It's a good day. X percentage. All these three things can be converted between each other, and they're all equivalent versions, all right? Just different ways of representing the same stuff, okay? Now, some things can't be represented in fractions rationally like this and that, but that's a sort of whole new different class of number, all right? But the main thing we'll be looking at is being able to sort of go anywhere around inside this these three here, different representations of the same thing. Okay, some key ideas for us: being able to convert decimals to a fraction. So if we look at this number here, 0.37, you'll notice that got 0.37, we have 37 hundredths. Okay, so if we've got 37 hundredths, okay, because remember this is the tens column here, and this is the hundredths, so we have 37 hundredths. So we can write this as 0.37 is equivalent to 37 over 100, okay? 37 divided by 100, remember that idea of division's the same kind of thing as fractions, okay? Now, when we're looking at this, we've got to make sure that when you're converting decimals over a fraction, that you then represent it in its simplest form. Okay, let's have a look at this. 37 over 100. Well, 37 is a prime number, so we're done. Okay, so that one there's, well, and it's not a factor of 100, obviously, so we're just going to leave it as it is. All right, moving on to our next one, 4.15. So that might look a bit scary to turn that into a fraction. However, we're going to sort of come in with a bit of a mixed number action here. So 4.15. 4.15 is equal to, right, if we look here, we've got a whole part of 4. So that means we can have our 4 out the front for our mixed number. And here we've got, as before, we looked at, that is 15 hundredths. Okay, so that means we can have 4 and 15 hundredths. Okay, now can't just stop there, because 15 and 100 are both divisible by 5. So we're going to have 4, we're going to divide by 3, divide by 5, divide by 5, and we will end up with 4 and 3/20. Okay, that's how we go about that. When there's a whole part of the number, it's probably easiest to create a mixed number like that. Okay, converting fractions to a decimal. Now this is pretty easy as well in some instances. So this one here, when you've got it over a power of 10, okay, so here the denominator is a power of 10. So that one, denominator is a power of 10. If that's the case, set it up as a division and carry it out. So 6 over 100 is the same as 6 divided by 100. And if we remember from a couple of videos ago, all we need to do now is move our decimal point 1, 2 places, and so we're going to get 0.06. Okay, so that's how we go about the fractions if the denominator is a power of 10. Okay, if in this situation here the denominator can easily be made into a power of 10. So here, easy to make into a power of 10. Okay, typically by multiplication. Okay, division doesn't always work because that should be in a simplest form and stuff, right? So, turns out, for those of you playing at home, 2 times 50 is 100, right? So that means that if we have 11 over 50, I can times the top by 2 times the bottom by 2 and get 22 over 100. And if that's the case, that's the same as 22 divided by 100, which, if I move my decimal point here, we're going to get 0.22. Okay, so that's the sort of the times we're going to find it pretty easy. Okay, this last one here is where it can't be made into a power of 10 very easily at all. If this is the case, you just need to carry out the algorithm. Okay, so since 65 over 7 is the same as 65 divided by 7, we're just going to carry that algorithm out. 65, 7. Actually, I've got a feeling about this where this is going to go. Just going to give myself a bit of room. So 65 divided by 7. 7 into 6 is 0. 7 into 65 is 7 eighths of 56. Remainder, no, 7 nines is 63. 7 nines, remainder 2. So I'm going to get 2, 0. Okay, 7 into 20 is 2, remainder 6. 7 into 60 is, that's our 7 eighths, 56, and so we're going to have remainder 4. 7 into 40 is 5, remainder 5. 7 into 50 is 5, 7, 6. 7 sevens is 49, remainder 1. 7 into 10 is 1, remainder 3. 7 into 30 is 4, remainder 2. Okay, finally we're there. Right, so you'll notice that now we're back at 7 into 20 again. We just did that earlier up here. Okay, so because it's got that again, you know that this is just going to get repeated again and again. And what happens when you're dividing by 7, if it's not a factor of a multiple of 7, you're going to get this annoying repeating kind of section here. Okay, now, there's a couple of ways that we can show that. All right, so we're going to come down here and show that division can sometimes result in these things called recurring decimals. All right, so what do we have? We had 65 divided by 7 is equal to, right? So 9.285914. So we can either show this, by putting some dots here and here. Because what that means is that everything between these dots, inclusive, just gets repeated over and over and over and over and over and over and over again forever. Okay? So, or another way to show it is 65 divided by 7 is equal to 9.285914, and then putting a line over all of the ones that get repeated over and over and over and over and over again. Okay, so that's our couple of ways of showing this idea of recurring decimals. Now, if it's not a sort of a pattern that gets repeated, sort of like 1 divided by 3 is 0.3333, and that just goes on forever. You can just put a dot over the individual number that gets repeated forever. Okay, so that's a lot of the sort of stuff to sort of swallow there. There's a few different ways of going in between our decimals and our fractions, so make sure you're giving yourself a chance to practice every single different type, so there's nothing that you're going to get trapped on. Okay, thank you so much for watching, and come see me in class if you're having any issues. Thanks.